Okay, in this lecture we're going to talk about simplifying radicals using exponents. We already have looked at how radicals and exponents are related together. So let's look at some examples where actually breaking the radical down into an exponent is actually beneficial in helping to simplify. So let's simplify. Right, let's suppose I have the 10th root of the square root of 3 to the 5, then this will in fact be, we know that the 10th root will in fact be 1/10 power, exponent or power, so this will be 3 to the 5 to the 1/10. Now we use our exponent rules. This will be 3 to the 5/10, which is of course 3 to the half, which of course is the square root of 3. Okay. Right, let's do part B. Let's suppose I have the cube root of x to the 6, y to the 18. Right, here of course we have, this will be x to the 6, y to the 18, right, to the 1/3, and this will be x to the 6 over 3, y to the 18 over 3, so this will be of course x squared, and y to the 6. Notice I don't need any absolute values here because these are positive. This will be positive when it's squared and positive when it's powered of 6. Right, part C, let's suppose I want the 6th root of the cube root of 4 squared. Right, well this will be 4 squared. Let's start from the inside out. This is a cube, so this will be 1/3 power, and then it's to the 1/6 power. So this will be 4 to the 2 times 1/3 times 1/6, which is 4 to the 2 over 18, which of course is 4 to the 1/9, which of course is the 9th root of 4. Alright, so that's how we do those. Now we want to multiply radicals. Okay, right, so let's look at an example. Now the good news here is that if they're binomials, we just use the FOIL method, or we just use the distributive property. So let's find each product. Right, part A. Right, let's suppose I have the square root of 7 plus the square root of 5 by the square root of 7 minus the square root of 5. Right, using FOIL, of course, we'd have this would be the square root of 7 by the square root of 7, which is 7. Then we do the outer ones, which will be minus the square root of 7 by the square root of 5. Inner ones would be plus the square root of 7 by the square root of 5. And then the last ones, of course, which would be negative square root of 5 by square root of 5 is 5. So I end up with 7. These cancel. Alright, minus 5, which is 2. And this is like the difference of 2 squared property we had here. It would be the square root of 7 squared, which is 7, minus the square root of 5 squared, which will be 5. Alright, let's do the next one. Let's suppose I have 5 plus the square root of 32. And we multiply this by 3 minus the square root of 2. Again, we do the FOIL. 5 3s are 15. 5 times negative root 2 is negative 5 root 2. Inside here we get 3 square root of 32. And square root of 32 minus times negative root 2 is negative square root of 32 by the square root of 2. So this becomes 15 minus 5 the square root of 2. Plus 3 by the square root of 16 by 2, minus, of course, the square root of 32 times 2, which of course will be 15 minus 5 root 2, plus, now a square root of 16 is going to be 4, 4 3s are 12, square root 2, and this will be minus the square root of 64. So this will be 15. Now let's have a look here. Negative 5 root 2 plus 12 root 2 is 7 root 2. And the square root of 64 is 8, minus 8. So I end up with 7 plus 7 square root 2. Right, the next thing we want to talk about is rationalizing denominators. Now, rationalizing denominator means that we want to get rid of the radical in the denominator. So let's look at the first one. Let's look at, suppose we have 4 over the square root of 5. Now I want to get rid of the square root of 5 in the bottom here. So to do that we use a little trick in mathematics, which is to multiply by 1, but this 1 we're going to represent as the square root of 5 on the square root of 5. Because I know that the square root of 5 by the square root of 5 is 5, and on the top I'll have 4 root 5. So that's my result. Alright, let's do part B. Let's suppose I have the cube root of 4/9. Now this is an interesting one because we have the cube root. Now the first thing we do is we apply the radical rule of quotients. Now notice that we have a cube root here. Now how do I get rid of a cube root? Well, I've got to cube it really, don't I? So to do that I really need to multiply this and then do it again. So now I've got cube root of 9 times the cube root of 9 times the cube root of 9 will give me 9. So of course I'll need it here as well. Alright, so what we end up with here is the cube root of 9 by the cube root of 9 by the cube root of 9 is 9. Don't want to try and say that too hard, too fast. So that would give me 9 because I've got 3 of those here. Now I'm going to have the cube root of 4, and we have the cube root of 9 times the cube root of 9, which of course will be the cube root of 81. So this will be the cube root of 4 times 81, which is 324 on 9. And now we look for cubes inside 324, and I believe it'll be 27 times 12, which will be 3 cube root of 12 over 9. This cancels and we're left with the cube root of 12 over 3. Okay. All right, so that's how we do that one. That's how we rationalize denominators. Now we will revisit this later when we have a binomial at the bottom, so that we'll show you how to rationalize those kinds as well.